let's say you've been asked to create a representative sample using random selection, which is our typical go-to, as a way of avoiding bias. What sample size would you want if you could choose between a sample size of 5, 25, 100, or 1,000? If there's no costs involved, go with the sample size of 1,000. For a sample size of 1,000, you are going to get sample means that are very close to the true population mean. The sample standard deviations, likewise, will be really close to the population standard deviation. And the skewness of those samples, likewise, very similar to that of the population. We would call these 10 examples of samples as representative. So here's our population with the population mean of 24, and here are those samples of size 1,000. Really close. So sample size 1,000, you're going to get a very representative sample. Generally, though, we don't have the money or resources to have a sample of size 1,000. So what about a sample of 100? So sample of 100, we're seeing now more variability in the sample mean, in the standard deviation, and in the skewness. In terms of representing what we see in the population, these samples are getting a little less clear in terms of the shape of the distribution. The sample means still fairly good, in some cases excellent. Where the sample mean is varying from the population mean, we call that sampling error. And that would make the sample be considered less representative. Whereas when the sample mean and the population mean are like right there on top of each other, sampling error is minimal, almost zero, and we would consider this, in terms of the sample mean, highly representative. Okay? But again, usually we don't have the resources even for 100 participants. For example, psychology, often we're working with a sample size of 25. In that case, when the population mean is 24, here our sample means range from 21.92 to 25.48. So that's a little bit more variability in the sample mean, a little bit more variability here in the standard deviation, and a little bit more variability in terms of the skewness. And when we look at these samples, again, they're giving us an idea about the population, but imagine if you were taking a picture of something. At a sample size of 1,000, you've got perfect resolution, or pretty close, right? Sample size of 100, now it's starting to get a little bit blurry. Sample size of 25, getting even blurrier still. Finally, let's take a look at a sample size of 5. So here we go. Sample size of 5. Now these sample means are ranging much larger, from 23.8 to 29.8. Standard deviation is anywhere from a 1.92 up to an 8.09, and skewness likewise pretty much all over the place. So a sample size of 5. Now in terms of that camera analogy, our image, we can kind of make things out, but the image is so blurry that the resolution is so poor that we can only make out something that's really big. And I think that's an important point. Sample size of 1,000, you got awesome resolution. You can see things with really fine detail. It's going to stand out, small differences. As your sample size decreases, sample size 100, your resolution's not quite so good, the image is a bit more blurry. Now it has to be bigger for you to notice it. Sample size of 25, at that point, even more blurry, poor resolution, has to be even bigger to be noticed. And a lot of researchers are really good with that, because in a way, if they're going to report something to the general population and to their colleagues, they want it to be big enough to get excited about. And a sample size of 25, in a way, says, I'm not interested in the really small details. I want it to be big enough to jump out at a size of 25 so that it catches my attention and I can then share it with others. Sample size of 5, that it becomes so blurry, so poor resolution with our metaphor of a camera, that it's unlikely we're going to find as many things of interest. So over time, we've found that a sample size of 25 works really good. In terms of its representativeness, well, it is randomly selected, so there's no bias, but it's not quite as representative as we'd often like. We have to keep in mind that there will be sampling error when our sample size is 25.